Children, I'm going to pick up some questions from exercise 7.2, and the first question which I'm picking up is prove that the curves xy is equal to 4 and x square plus y square is equal to 8 touch each other. Now we have to remember two things over here, that is, if the two curves touch each other, then there has to be one point of contact which will be unique. Another thing is that when they touch each other at that particular point of contact, the slopes have to be equal. So therefore my first aim is going to be to find the point of intersection of the curves. So I'm making the first equation. In that I'm making y as a subject, that is y is equal to 4 by x, and I'm going to put that in the second equation there, which is going to give me x square plus 16 by x square equals to 8. Now, this finally reduces and simplifies to give me x square minus 4 the whole square, giving me 0, which now further can be solved and we can get the answer as x is equal to plus minus 2. Now when I put this x is equal to plus minus 2 in the first equation, I get the corresponding value y as plus minus 2, which when substituted in the form of points gives me 2 comma 2 and minus 2 comma minus 2. Now you can see that there are 2 points of contacts over here, or it could be points of intersection, because just now I do not know whether they are going to touch or they're going to intersect. So generally speaking, they are the points of intersection. But we have to now verify that if the curves are touching each other, then the slopes at that particular point of contact should be equal. So I am differentiating the first curve, that gives me dy by dx as minus y by x. And when I am substituting the points 2 comma 2 and minus 2 comma minus 2, I get the slope as minus 1. Similarly, I am differentiating the second curve also, and there also I get the slope as dy by dx, which gives me minus y by x. And in this also I have substituted the point 2 comma 2 and minus 2 comma minus 2. This also gives me the slope as minus 1. Now I have noticed that the slopes of the two curves at the 2 points of contacts is minus 1 each. So therefore that verifies or that proves my statement that the two curves intersect each other, or they touch each other at the point 2 comma 2 minus 2 comma minus 2. The next question which I would talk about is, it says find the condition now this time the between the curves given to you as 2x is equal to y square and 2xy equals to k, that they intersect orthogonally. I hope you remember, when the two curves intersect orthogonally means that they are perpendicular to each other. Now in this also I am going to take the two curves. One is 2x is equal to y square and the other is 2xy is equal to k. From the first one I have made x as a subject, which gives me y square by 2, and putting it in the second one I get the value of y as k to the power of 1 by 3. And when I substitute this value of y as k to the power of 1 by 3 in the first one, I get the value of x as correspondingly k to the power of 1 by 3 whole square by 2. This gives me the point in terms of the k as k to the power of 2 by 3 by 2 and k to the power of 1 by 3. This is the point of intersection which I have obtained over here. Now again see, since they are intersecting perpendicularly, orthogonally, that means there is one point of contact, and at that point of contact, the slopes have to be equal. So therefore again I am differentiating the two curves with respect to x. When I do for the first one, I get dy by dx as k to the power of minus 1 by 3. That means this is going to be the slope of the first curve in terms of k. Similarly, I do the differentiation of the second curve given to me as 2xy given as k. When I differentiate that, then dy by dx comes out to be minus 2k to the power of minus 1 by 3. This is the slope of the second curve now. Now, like I had said earlier only, that if the two curves intersect at right angles, that is, they're perpendicular to each other, then they should satisfy the condition of perpendicularity. That is, m1 into m2 should give me -1. And when I substitute the values of m1 and m2 in this particular condition, I get the corresponding value of k as 2 root 2 after solving it. So I get the condition that if my k is equal to 2 root 2, then these two curves given to you as 2x equals to y square and 2xy equals to k will intersect orthogonally. Now the third question which I am taking up is, find the measure of the angle of intersection between the curves, that is xy equals to 6 and x square y equals to 12. Now in this also, the first aim is going to be to find the points of intersection. I am putting the first equation in the second one to get the value of x as 2. When I put the value of x as 2 in the first equation, I get the corresponding value of y as 3. So I have got my point of intersection, that is 2, 3. Now again, if the two curves are intersecting, that means the point of intersection is given to you, the slopes have to be calculated at that particular point, and these lines are cutting each other at some angle. So therefore, when I differentiate the first line, which first curve, that is xy is equal to 6, I get my dy by dx as minus y by x, and the point of contact or the point of intersection has been given to me as 2, 3, which I've already calculated in the step 1. So now dy by dx, or the slope of this first curve, comes out to be minus 3 by 2. Similarly, I am going to differentiate the second curve also, which gives me the dy by dx as minus 2y by x. Now in this, when I put the point 2, 3, I get the slope as minus 3. Now I know the formula of the angle, that is angle between any two lines is given as tan inverse of mod of m2 minus m1 whole upon 1 plus m1 m2. In this, I am going to merely substitute my two slopes. M1 has been taken as 3 by 2 and minus 3 by 2, and M2 is minus 3. When I substitute that and I solve it, I finally get the answer as tan inverse of minus 3 by 11. Now, the next question, question number 22, which talks about find the equations of the normals to the curve 3x square minus y square equals to 8, such that the normals are parallel to the line x plus 3y is equal to 4. Now in this, let's see. My first equation, my first curve is 3x square minus y square is equal to 8, and the second one is a line, that is x plus 3y equals to 4. I differentiate the first one. When I differentiate the first one, I get the slope of that curve, which you can see is like a circle, comes out to be 3x by y. Now slope of the tangent to this curve will be minus y by 3x. Right? Now the slope of the given line, that is x plus 3y equals to 4, I know the definition says it is coefficient of x upon coefficient of y, negative of it, so therefore minus 1 by 3. Now it's given to you in the question that the normal is parallel to the given line. So therefore the slopes have to be equal using the condition of parallelism. Now when I say that the first slope and the second slope are equal, I get the condition as y is equal to x. Now I'm substituting the value of y in equation 1. When I do that, I get the corresponding value of x as plus minus 2. Now when I do that, x is equal to plus minus 2, I get the corresponding value of y as plus minus 2. That means the points of intersection are coming out to be 2, 2 and minus 2, minus 2. Now, 2 points are here, that is x1, y1, and the slope is given to you that you've already calculated, which comes out to be minus 1 by 3. Now I'm going to simply make use of the formula of the equation of the line passing through a given point whose slope is given to you. That is y minus y1 equals to m times of x minus x1. So the first point which I am considering is 2, 2. So I get y minus 2 giving you minus 1 by 3 times x minus 2, which results in finally x plus 3y minus 8 giving you 0. So I have been able to obtain the first equation of the normal at the point 2, 2. Similarly, the second equation which I get, now the second point is minus 2, minus 2. Again using the same formula, y minus y1 giving you m times of x minus x1. I have substituted this time x1 and y1 are minus 2, minus 2. When I substitute that, then I get the equation as x plus 3y plus 8 giving you 0. So now you can see the first answer came out to be x plus 3y minus 8 is equal to 0. The second one comes out to be x plus 3y plus 8 is equal to 0. That means the equations of the two normals are x plus 3y plus minus 8